Flack math! Give me some math and I'll give you some flack. Flack math!
Here we go. So we're going to talk about power and roots of fractions. So powers and roots.
Wait, there's power and roots of fractions? Are you kidding me? Oh
Yeah.
no.
So
Oh,
it's just
no.
the same thing, right?
Oh.
So just a little bit of review. Austin, we're done talking about whatever you're talking about. Okay, what does this mean? What the heck does this mean?
2 to the 3rd power.
2 times 2 times 2.
Yeah, so you just take that, you multiply it by itself 3 times. 1, 2, 3. So you get 8, right? So we do the same thing with fractions. Okay, there's no difference. What does that mean?
1/3 times 1/3.
Yeah.
The answer is
So
1.
it's just 1/3 times 1/3 times 1/3, which is not 1. It's 1/27.
Well, 1/3 3 times is 1.
1/3 times 3. Does that say 1/3 times 3?
Basically.
No.
Oh,
No,
there's
very
a-
different. 1/3 times itself 3 times.
Literal AI.
Okay.
So you do 1/3 times itself, and then you multiply it again.
Yep. So here's another shortcut. So what did you do with the numerators? You just multiplied the numerator times itself 3 times, and the denominator times itself 3 times, right?
Yeah.
So another way to write this problem is just like this. 1 cubed over 3 cubed.
Okay.
It doesn't matter. Okay? It's not like you're going to cross reduce anything, right? So see if you can do this one. Ready? See how fast you can do this.
Maybe I need some paper.
1/2.
Yeah, sorry. We don't really.
4 9s. Okay, not 4 6. You add it. You don't multiply by 2. You add. So this is 2/3
Do another one. Now I know how.
times 2/3, which is 4 9s. Or in other words, 2 squared times over 3 squared.
Okay.
Okay, ready?
Yeah. Oh. Whoa, 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 whoa.
Whoa, whoa.
Whoa.
Oh, that is
3/16.
4.
Good job.
What?
So basically, what times itself equals that? So what fraction times itself equals that? Well, what times what equals 9?
3.
And what times itself equals 16?
Watch out.
So this is 3/4. Another way to think about this is if you have a square root of a fraction, you could just do the square root of 9 over the square root of 16. Right? What's the square root of 9?
3.
What's the square root of 16?
5.
4. Okay? Yes, sir.
I'm gonna correct you on the board. Stop. Gap.
You wrote the Verizon symbol instead of the root.
It's actually the
Square
van.
root.
That's the van.
That is very true.
What is
100%.
That's
All right.
3 problem sets for
Just
you.
said 4.
Okay, ready for one more? One more? Here's example 3.
No. Mr. Flack, I'm gonna correct you on the board. I forgot example 2.5.
And I'm wearing my mask too, so.
Oh.
This is
2 9.
2 9.
I said
Whoa.
first.
No.
No, it's
I
not.
said first.
2/3.
It's 2 9. It has to be.
No.
Yeah.
9 times 9 is 9.
Oh, 2/3.
That's right. Good job,
Oh,
Ben.
yeah, oh, it was cute. Dang it.
Ben, you do it for a while, huh?
Guys, believe me.
So, guys, just forget about the fraction and just do this. The cube root of 8
The cube root of 2 7.
over the cube root of 27. Well, cube root of 8 is 2. Cube root of 27 is 3.
No way.
Right? Because 3 times itself, 3 times 3 times 3 times 3 is 27. 2
Yeah.
times 2 times 2 is 8.
Can I go to gym now and learn?
All right. How do we feel? Are you ready to move on?
Yeah.
Yeah.
Okay.
3 problem set.
Do I get a free problem set?
Yes.
No.
I got 2 of them right.
I'll do a 3 problem set soon here. Well,
I
maybe
mean,
this
we've been in a
period.
dry spell for what, 3 years?
Please do it about that subject.
I got 2 of them right. Before everybody.
You did a good job on that.
That's because you had a better angle.
Yeah.
Yeah, you saw it before everyone.
Yeah.
Emerson saw it last.
8.5 out of 10.
You would have just gotten it way faster.
No, actually, I would have.
Stop the cap.
No, I would.
You'll stop the
Guys,
cap.
what do you
Stop the
mean?
cap.
Stop cap.
Okay, so this is, I think, a pretty new concept here.
Mr. Flack, you didn't write the thing up there.
Don't
Hey.
throw away their coffee.
Drop that.
Free coffee.
So we are going to graph inequalities. What the heck is an inequality?
A thing that's not equal.
Okay, good.
That wasn't a mistake.
Nothing can be greater than that.
Okay, so if x equals 2, how would I graph this on the number line?
You don't.
How would I graph x
You
at
put
2?
it on the 2.
Yeah, you just put a dot right there, right?
Yeah.
Okay, this is important. This is how you plot on a graph, x equals 2. So what if I wanted to say x is greater than or equal to 2?
Equal.
It would be.
You put the thing on the 2.
You do, because it could be equal to 2, but it could be greater than 2
You
as
have to
well.
draw a thing on the side.
Okay, so now we shade it in.
Yeah.
Yeah.
I remember
Okay.
this. Didn't we already learn this last year?
We might have learned it last year, yep. So does this make sense so far?
No.
So x is
Yeah,
not
for sure.
is not just equal to 2, it's also greater than 2. So we're going to shade everything that x is. X is equal to 2 and it's greater than 2. So it's to the right of 2. So far, so good?
X is kind of cracked.
Now there's one other thing.
You might adjust.
What if I just wanted to graph everything greater than 2?
Just with an X.
Then you do.
Then you draw a circle, but you don't fill it in.
Okay, good. Now, this is a new thing for some of you.
Then you draw an arrow.
Now, it's impossible
It
to
is.
get as close to 2 as I can without touching it. Because look at that. Look at your fingers. Now put your fingers together like this, maybe like a centimeter apart. Okay, do you think you can get twice as close?
Yeah. I got
Okay,
it.
now do you think you can get twice as close as that? Do you think you can get twice as close as that?
No, it's too far.
Now into the theoretical though, theoretically, you can keep getting twice as close, and never touch it, right?
Yeah, what?
Theoretically. Now physically, it's impossible.
What?
But theoretically, you can always cut a distance in half, cut it in half, an infinite number of times without ever touching it.
That's
Isn't
cap.
that
You made a
crazy?
mistake on the
Cap.
board.
Illegal.
You
Isn't
know
that
that?
blowing
No.
mine?
It wasn't on the board, but you didn't go.
Stop.
You didn't go at, precisely halfway when you did that. So.
Oh, okay.
No, man, there's actually cap. There's
Yes,
no way.
Austin?
So you have a mistake. So technically, nothing ever touches because of atoms. So technically,
That's right.
I'm not touching anything.
That's right. This is not even
No,
touching.
Mr. Black,
You know what I'm saying?
there's
Okay,
no way
now.
I can infinitely do it. It's just because there's a number, because the centimeters, then
Yeah,
it gets
That's
smaller.
why I
physically-
said theoretically.
Physically impossible.
I know.
But theoretically,
it's impossible.
not theoretically, it's not.
Theoretically, it is.
It's not
possible.
impossible.
No,
No, it's just impossible in general.
Ready, right?
Okay, guys, watch. Almost done. So I can't do this. I can't shade all the way up to there as close as I can without touching it. So here's what we have a symbol in math, and I call it the everything but.
Oh, wow.
It's a clock.
So it's an open circle. So it's kind of like this force field,
Everything
this
like-
invisible force field that protects 2 from being shaded. Okay? So this is the symbol you need to have, open circle. When it's strictly greater than 2, but not equal to 2, it's got to be an open circle. Can you remember that?
Yeah.
All right.
No.
Ben
So
said-
let's see if you guys can graph this.
It just is. Justin is a man.
Justin's back for Fortnite.
You Josh seen what's that
Justin
new
quit
Rocket League
Fortnite.
video?
Justin is now.
Hey,
Oh,
you
you guys
know,
Call of Duty
Among
and
Us-
Brady just because you can't build.
Hey Henry, you know Among Us from
Justin
Fortnite?
plays
Rocket League.
I love playing Among Us and then yelling I can't build when I
Mr. Flack is trying to teach us a lesson.
Okay, you guys, I know you guys aren't gonna put it on your paper because you don't have paper up, but describe to me how to graph this.
I'm as white as paper, so I
You
count.
draw a filled-in dot
Where?
on the one, on the negative one, and then you do the circle all the way that way.
Which way?
That way.
No.
Which way?
The right way.
This way?
The right way.
To the left.
No,
You're
we're going
right.
left.
The left
I
way.
meant to my right. Oh, wait,
Hey
no.
guys, look. You can literally read this left to right. X, you can substitute the word shade. I'm gonna go shade left, because that arrow points to the left. So I'm gonna go shaved, not shave, don't shave it.
Like,
Shade left and on top of -1.
yeah.
So see how I shaded left of -1 and on top of -1? And that's it. Can you guys remember that?
Yep.
Maybe.
So the hardest part about this, guys, is remembering whether to fill in the circle or leave it open.
Okay.
Now here's another way to remember it. If it takes more ink or lead to write the symbol, it's going to take more ink or lead to graph it.
If there's a line on the bottom, then there won't.
See how it takes less ink or lead there? So less ink or lead there. Okay? Any questions?
Yeah, I did.
That's all I got for
Okay.
today.
Black math. Give me some math and I'll give you some flack. Black math.